Today we're going to continue studying SQL programming. And the last class, I think we mainly covered the basic SQL statement. So then we discussed several kind of different methods for doing the substring pattern match. And also we talk about the nested query using the in operator. And also we're talking about using the order by clause to order the query results so that we can easily find the information that we are interested in. And today we're going to continue studying aggregate functions. So aggregate functions basically calculate the sums, average, count, minimum value, and maximum value of a particular column for a given table. And this table can be the base table, one of the base table we have, or can be the table that's produced by a query. And then we can further do the further group the records in the table and then apply the aggregate functions for each group.
Things are looking good. You got
Yes.
mic and everything?
Yes.
Okay,
Yes.
very good.
Okay, thank you.
Other two look operational.
Okay, so this kind of shows how we can of the employee. So basically, in one query, we produce all four consider statistics values. So first one we sum up, second one we do the maximum values, third and the fourth one we do the minimum and the maximum and average salaries. Okay. Then the distinct operator is also very important. So recall that in a relational database, every single table, for each table, it must have a primary key. So that means that every record in the base table must have distinct primary key values. So in this case, we don't have any duplicate records in the base table. However, when we run the query produced results, and the results can be viewed as a table. We call the resulting table. Then the query's resulting table usually will not need to follow that this kind of a primary key constraint because we may have multiple records identical that appear in the query result. Okay, so then the distinct operator is very kind of convenient. So basically means that if we use distinct operator in the select clause right before all the attributes in the select clause, then it will filter out all the duplicate records, only present the distinct records in the result. So here, for example, we ask the assistant of the distinct employees who are supervisors. So if you look at the employee table, we have a column called the supervisor's assistant. You can tell that basically means that a supervisor may advise more than one employee. So that's why we have multiple employees. They share the same supervisor's assistant. Okay, if you simply just list super assistant from employees, you're going to see quite a few kind of duplicates assistants. So let me first log on to my Apex account. So okay, so I just want to show you that if you do not use distinct, what we have here. So we do select super assistant from employee. Make sure it's a super assistant. Yeah. Okay. So if we run this query, it got a list of super assistants. So then you can tell that several values, assistants values, are repeating in the result. Okay. So this is because those in the query result. So in the query result, it can have duplicate records, okay? So, but if we apply the distinct right behind select and in front of all the attributes in the select clause, this distinct basically applied to the resulting table to make sure that only distinct records appear in the resulting table. So if we run this one, then we only have 3, okay? So then I think this distinct will be useful depending on your the question asking. So if you, for example, you want to see how many employees are are the supervisors, okay? So then the right one should be the count. So we use count. Distinct super assistants, okay? So this is how we do it. So if we do this one, then we have 3, okay? This is what we got here. But if we do not use distinct, then we simply just do the select count super assistant, then it simply just count the number of the super assistants in the resulting table. So what the database will do is that it first lists all super assistants from the employee table. So pretty much just simply list the super assistant column, and then it will do the count. So then it will count every single super assistant, regardless if they're duplicating or not, okay? So if we remove the distinct, then the count will be exactly number of the records in the table. So that's not what we want. So that's why distinct is pretty useful if you really want to ignore all the duplicate records and then do the statistics on the distinct records. Then you have to use distinct. Then the goodbye clause. So goodbye clause basically means that once we have a table, either the base table or the table produced by the query, the resulting table, the goodbye will allow us to group the records by a specific attribute value or a set of attributes values, okay? So means that, for example, if we group by a single attribute value, then the records with the same attribute value will put into a group, okay? So once we partition the records into groups, then we can further apply the aggregate functions. So in this case, each aggregate functions will only apply to each group. For example, if we go by produce like 10 groups, then if we apply an aggregate function like count, then it will produce counts for each individual group. So finally, we're going to have 10 counts, one for each group. Okay, so aggregate functions, if we use goodbye clause, aggregate functions will be applied to each individual group. Okay, so then in overall, we have this kind of we can have the possible 5 statements in SQL query. So we have select from, it will be the must, the statement we have to have. Then the where clause is optional depending on whether we will only interested in some records that satisfy certain conditions. Then the goodbye, if we want to group the records, basically, if we have goodbye here, it's pretty much the query, the database will first generate a query result based on the select from where clause, and then the resulting in the resulting table, it will group the records by either a single attributes value or a set attributes value. Then the having clause basically will specify the conditions on the group. Okay. Then the select clause, we need to list all the attributes. So once you apply the goodbye in your statement, in your query, that means that you no longer be able to retrieve each individual record. So then means the resolution level is not at the record level, it's rather at the group level. So for each group, you can only output the group index. So what is group index? So group index determined the attributes list in the group by class. Okay, so for example, if we have 3 attributes in the group by class, then these unique combined values of those 3 attributes will make a group. Okay, group index. Okay, then the select class, we can only query the group index. So that means that in the select class, the attributes list in the select class can be only those attributes appear in the group by class. Because once we use group by, then we no longer be able to distinguish each individual record. We can only distinguish each individual group. Then for each group, we can apply the aggregate functions to calculate some statistics. So that's kind of how the order of a typical SQL statement will be. The having clause simply just specify a condition that a group must satisfy in order to be included in the result. So having condition usually always query about the group statistics. Okay, so let's see some examples. So hopefully it can help you to understand. So this one, for each department, list the department number, the number of employees in the department, and their average salary. Okay, so it's talking about the department number of employees for each department, and the average employee salary for each department. So in this case, we are not calculate the individual employee salary. Rather, we focus on the average salary and the number of employees for each department. So regarding to the table, we do have department table, but we do not have the employee information. We do not have the employee salary. But if you go to the employee table, we do have employee salary. We also have employee D number, okay? And so I think that's pretty much should be enough. So how do we write this query? So in order to answer this question, we first have to group the records of the employee table by their D number, okay? So employees of the same DNO will be put into a group. So in this example, we have 3 distinct DNO in the employee table, 5, 4, and 1. So that means that after the group by, we're going to produce 3 groups, one for the DNO 5, one for the DNO 4, and one for the DNO 1, okay? And each group should contain, at least 1 employee record, maybe more, okay? So once we perform, we derive those groups, then we can apply the aggregate functions. So for example, we can count the number of the records in each group that indicate the number of the employees. We can also do the salary, average salary for each employee. I think one of the math is not
black and
okay.
line. वो गन में आइल बताया है ना?
Kuma, Manaji, your Mac is on. You have to turn off your Mac.
115.
New one
है old one.
Manaji Kuma. Kama, I don't know.
10 months, 7 months when you left to yeah. This is also new one, but they have oil.
So please turn off your Mac.
तुम्हारा
अभी आ रहा है
now?
हाँ ये वो करके जाएगा ना मुझे जो सोचे मैं कॉल तू जा रहा है उधर जा रहा है कहाँ जा रहा है
ग्रोसरी में बहुत सारा टिकट है
मैं तो
Okay, I have to force to mute him. Sorry. So then once we have this group, we can count the number of the employees. We can also do the average salary. So this is how we do it. So we do the select from, this should be the employee table, okay? Then we're going to count every employee. So that's why we do not have where clause, but we do need to have group by clause. So this group by clause basically decide how do we group those employees. So we're going to group them by DNO. So this DNO is called group by key, okay? And then in the select clause, the same thing. So select clause, we can only output the attributes that appear in the group by key. So that should be DNO, nothing else. Okay, because that's DNO stands for the what? Stands for the group index. Okay, then we can count. So this count basically will apply to each group. So count, I think simply we just put count asterisk. So that indicate we simply count the number of records in that group. And then next one, we're going to do the average salary. So we do have a salary column. Okay. And then that's it. Okay, so let's test this one to see. So we know that since we only have 3 distinct DNO, so we can expect that this query will produce 3 records, so 1 for each group. So group index will be DNO. Then the count means that for the department 1, we have only 1 employee. The average salary will be that employee salary. Then for department number 5, we have 4 employees, and the average salary is this number. So you can tell that this is very convenient for us to generate some report, okay? Okay, then for the having clause. So having clause, for example, we may not interested in every group's statistics. We're actually interested in certain groups that satisfy some condition, but those conditions should be only specified by those aggregate functions that count the number of the records, the average values for certain attributes, or the maximum value, or so on, okay? So let's see the example here. For each department with at least 3 employees, list the department number of employees in the department, then and their average salary. So this is very similar to the previous one, except that it does not want to output this number of employees, average salary for every department. It's only interested in those informations for the department with at least 3 employees. So that basically means that we can write a very similar SQL query, but we have to have the having clause to only kind of specify the conditions that each group must satisfy in order to be included in the result. Okay, so I think group by DNO, so that's what we have here. Originally we have a DNO, that's the group index, and count. So count asterisk is a very popular aggregate functions. Just simply count the number of the records in a group or in a table. Okay, then the average salary, okay. But if you only write a query like this one, it's identical to the previous one, so we don't care how many employees the department has. So in this case, we do care that we want the number of employees for each group is at least 3. So then that's why we want to have this having clause. So having clause we use to specify the group condition, and group conditions will be always the conditions about those aggregate functions, because that's the because when we use group by, we will not be able to identify each individual record. We actually can only identify each group along with some group statistics that can be produced by the aggregate functions. So here having means that for each group we need to count the number of the employees in that group. And then we're only interested that group has at least 3 employees. So that's why we have having clause. So this having clause basically will restrict which group will be included, will be put into the final results. Okay. So if you run this query, so we get only department 4 and 5 satisfy this condition. Okay. For example, this is about the the count. So we can also do the average salary. For example, average salary, for example, greater than 30K. Okay, so let's run this one to see what we have here. Okay, and all three departments satisfied. How about we pick like 40K? Then there's only one. Okay, so this shows you that how we can use having clause to specify the conditions that a group must satisfy in order to be included in the query result. So this is another example that we need to use having clause. So for each employee working on more than 2 projects, list their SSN and the total number projects they work on. Total number of projects they work on, okay? So in this example, it's asking the employee project work information. Although in our table, we do have project table, a project table only contains project info, okay? Like project name, project number, project location, and DNOM, but does not contain any employee project work information. But we do have worksum table that contains each employee's SSN, the project number he or she is working on, and the number of hours that he or she is working on that project, okay? So then we think about if this table is enough for us to answer the question here in the query. So it's asking for the employee who work on more than 2 projects. Okay, so how do we know if an employee work on the number of projects an employee work on? For example, if I'm asking like employee with SSN as 1, 2, 3, 4, I hope you're able to view it. Okay. So if I'm asking like employee with SSN 1, 2, 3, 4, 5, 6, 7, 8, 9. So then how do you know how many projects this particular employee working on? You just simply find the records with this SSN, okay, in the worksum. So you retrieve all of them. So then the number of the records with this SSN will indicate the number of the projects that employee works on, because each record is about a particular employee on a particular project with a specific hours on that project, okay? For example, for this 1, 2, 3, 4, 5, 6, 7, 8, 9 employee, he or she is working on actually 2 projects, okay? Project number 1 and 2, and have different hours, okay? For example, if you're looking at this one, like a 3, 3, 3, 4, 4, 55, 55. So this person actually worked on 4 different projects, okay? So 2, 3, 10, 20, and with the hours on each project. So this basically shows that if we manually trying to find out how many projects that an employee work on, we basically have to group, in this case, in the SQL tool, we group the records by SSN, okay? So if we have like 7 distinct SSN in the worksum table, then we're going to have 7 distinct groups. Then each group contains at least 1 record or maybe more. Then the number of records really indicate the number of the project that that employee works on. And then we can also do the sum hours. So that's kind of idea what we're going to do answer this part. So we're going to use worksum table, and that table gives us SSN information, number of projects, and the work on, okay? So then we need to group by, this is very important. In fact, we need to specify the group by key, so that should be the ESSN, okay? So once we have ESSN, okay, then I think it's asking for each employee working on more than 2 projects. So we can select ESSN, then we can count star. So count star basically means that we're going to count the number of records for each group that identified by a unique SSN. And this one is asking that employee working more than 2 projects. So that's why we do have having clause. So for example, for the employee working on only 2 projects, that's not satisfy this the question asking for. So we should have the count greater than 2. Okay. So in this case, we first group the works on records by ESSN. Then for each group, we count the number of records. Then we're going to examine if the number of records greater than 2 or not. If yes, then we're going to output the corresponding ESSN plus the count. So that's how this part, the logic here. Okay. Okay, so in this case, we don't have one employee who actually working, I think, more than 2. So I think remaining basically will be working as, I think, at least 1 project, maybe 2. Okay. So if we do not have this having clause, then we simply just output. For each ESSN, we output the number of the project that the employee works on. Okay. Now we have, see, we have some working on 2 and some working on 1. Okay. And only 1 working on 4. Okay. So if we change the having clause into the having count greater than 1, okay, not 2, then we're going to have more employees satisfy this condition. In this case, we have 6 employees satisfy this condition. Okay. Questions? Okay, this is the count. So aggregate function is actually very useful because usually in practice in the company, you may have to use aggregate functions to do some statistical analysis. For example, the total number of sales for a specific store, or total number of sales for a specific merchandise, or total number of the employees visit, for example, that store, or I mean, for example, went to the theater. So there's so many things you can use aggregate functions to retrieve the information about the sales, about the numbers, or about the trends. Okay. Good. So then in the SQL query, we have a special treatment to the nulls. So I think if you see that in our table, we do have nulls. For example, in this works on table, we have this employee and he's working on the project PNOS 20, but we don't have his hours or her hours on that project. So now in the database usually means several different things. One is that a data is missing. We don't know the values. I think this may be the case for the works on the last record. Sometimes it's now indicate the data is kind of not applicable. I think we do have it. For example, in this employee table, we have kind of a last people like James Borg, and his supervisor is set as null. So that means that he may not have supervisor. Maybe his CEO, his highest rank in the company, so he does not have supervisor. So null can be means not applicable, can be missing, or sometimes for security purpose null indicate the values there, but you're not allowed to access. Okay, so that's why in the database we try to avoid the null values in your data because it's really kind of cause confusion. Okay, so if we are trying to query the data that is conditioned that a specific field has null value, then we're going to use is, this comparison operator, so it's not equal to. Okay. For example, find the SSN and the names of employees who do not have a supervisor. So in the where clause, we have supervisor is null. So the whole query looks like select SSN, F name, L name from employee where super assistant is null, okay? So you can also set is not null. So that's basically the way you specify the null values or not null values. That's the special treatment for defining the null value using is, okay? For example, if we run this query, we will have James Ford, okay? So if we change is not to the is not, okay, then it's only filter out the records with super assistant as null, and then remaining records will be put into the result. Questions? So let me see. I think we may have some time to work on maybe in class exercise. So for each project, list the project number and the total number of employees working on it. So this is very different from what we see in the example. So it's asking for each project, list the project number and the total number of employees working on it. So I think we're still able to use workout table. The workout table gave us almost everything. It gave us the P&O, okay? It's also each record indicate a specific employee working on a specific project with certain hours, okay? So how do we know, for example, given project 1, how do we know which employees work on it, okay? So if we do it manually, we have to go to the employee table, workshop table, sorry. Then to find the records with P&O as 1, okay? So in this case, we have 2. If you're talking about like project number 3, then we have also 2. If we talk about project number 2, we have kind of 3 records. So this is actually can be translated into the SQL queries that we first group the records by the P&O, okay? So projects or the records with the same P&O will put into a group, okay? So that group really shows all the employees who's working on that particular project. Then within each group, we are able to count. So the count number of the records that will be basically will be indicating the number of the employees working on that project. So that's how we write this query. So we do the select. I think before do the identify the table we need, okay? Then we need to work sum, so we need to determine what we're going to group by. So the group by key will be P&O this time. The last time I think we grouped by the SSN, okay? So once we identify the table, identify the group by key, then the database knows exactly what we're going to do. So it will group the records by P&O. So it's formed the group, okay? So I think we have about 7 different, six different P&O. So that's why we're going to form this group by will form 6 groups, okay? So each group will be identified by the particular P&O number. Then for each group, we can simply count the number of the records in that group. That's really indicate the number of the employees working on it, okay? So that's semicolon, and that's it. So it shows for each group, for each project number, it shows the number of the employees working on it, okay? And for example, if in this case, we do not count every employee for a project, we may only specify for maybe payment purpose. We want to specify what the employees whose project number, whose project hours is greater than 10, for example, greater than 15. Okay, so we can do that too. So in this case, the database will go to the worksum table first, filter, identify the records, satisfy the hours greater than 15. Okay, then it will form the group. So pretty much this part of query will produce a resulting table contains the records in the worksum table with hours greater than 15. Then for those records, we do the group by PNO. Then we count the number of the people satisfy this one. So this kind of another possible way we can write the group by clause with we do have the where clause used to specify the conditions that a record in worksum must satisfy to participate in the group by. Okay, if you run this. In this case, I think we missed that project number 20 means that in the number 20, none of the employees working on more than 15 hours. The remaining we do see some kind of numbers. So here I just give you one example to show you that we do are able to have a where clause to first filter out the records before those records are partitioned into groups. Then the having clause is a different story. Having clause basically once group are formed, having clause will be used to further specify which group will be qualified to put into the result, which group will not. Okay, so that's those about group conditions. So where clause is about the kind of the record condition, or when we're talking about the table joins, the where clause also used to specify the join condition, and the having clause only used to specify the group condition, and it must be used with group by clause. The second one, for each employee working on more than one project, retrieve their assistant and their total project hours. I think we have already discussed this question in the previous slide about we group by ESSN, then we count the number of the records. Okay, so let me see what's the last one. Okay, this is kind of the very so this is a little bit kind of I want to leave this one for you. So the hint that we can use the in operator, but if you cannot solve this one by using the in operator and nested query, then I think we can discuss this one in the future classes when we're talking about the table join. Okay, good. So now I think I want to discuss the query multiple tables. So far, we kind of discussed single table query. So that actually happens when from a single table we are able to get all the information we need. Even for the aggregate functions, we only need the one single table to answer the questions. Querying multiple tables, that is actually very common practice. Why? Because in a relational database, the reason we call it relational means that tables are related. Okay, so if the table are isolated, then that's not relational database. And usually, if you recall that, how do we know table are related? So when we draw the ER diagram, when we design the database using the ER diagram, we have those diamonds to connecting the entity types. Those diamonds actually describe the relationship among the data of different entity types. But when we come into the relational table, relational database, actually the relationship among the tables usually will be defined by those foreign key and the reference key. So for example, if you look at maybe dependent, okay? So the dependent table only contains employee SSN along with some dependent information. So if we try to find the employee's name, so then dependent table is no longer enough. So for example, we want to list each employee's ESSN along with the employee's name and then the dependent's name. Then the dependent table is no longer enough. However, because of this foreign key in the reference key, we know that ESSN must reference some SSN given an ESSN in the dependent table. ESSN must reference to some SSN in the employee table. Okay, so what we need to do is that given a specific ESSN in the dependent table, we use that ESSN to look up the records in the employee table to find the record with matching SSN. Then that employee record actually indicates the record for that specific employee. So then we can retrieve the corresponding name information. You name it, like birthday information, address information, sex information, salary, and so on. So that's exactly what we call the table join. Means that we need to combine information of multiple tables together to get a more overview picture of the data or to get the information we need. So that's called a table join. So usually we may need to join table more than 2. Okay, we may join more tables. Where is it? Okay. So join tables actually means that we need to find columns with matching data. So those columns with matching data usually specified, identified by a foreign key and its reference key. Yeah, those columns, their values are pretty much kind of related. So a foreign key can only take one of its reference key value or none. So that's basically you need to understand. Okay. So once again, I want to kind of so for example, the DNO of the employee table is a foreign key reference to the department number of the department table. So because of this foreign key and the reference key relationship, then we know that every DNO's value in the employee table must be one of those D number value in the department or the null value, okay? So in this case, we are really able to validate whether a DNO's value is valid or not. So for example, we take the first one, DNO as 5, then we're able to find the matching D number in the department. So we know that this DNO is valid. So we can validate each individual one, okay? For example, assume for some reason, maybe the data entry problem, we found out that, okay, one employee has DNO as 7, okay? Then since there's no department number as 7 in the department table, we know that DNO as 7 is invalid. So this actually foreign key and the reference key relationship have been widely used to validate the database, the data validity. So I think majority of you from IQ. So those is very useful tool to evaluate whether a foreign key field has a valid value or not. But I want you to make sure understand that valid value doesn't mean the accurate. So what does that mean? For example, maybe if you look at first record, assume that John Smith actually working for the department 4, but not 5. Okay. So then if we look at 5, we think, okay, this is a valid department number. But this 5 might be not accurate if John Smith worked for department number 4. Okay. So, but anyway, so validity, accuracy, and timeliness, and there are a lot of DQ dimensions. So validity basically really validate if the data value is valid. Okay. It has nothing to do with accurate, but at least we can say it's valid. Like domain constraint also help us to evaluate whether a field has a valid value or not. For example, we have SSN, so we know SSN in this case. Assume that SSN is represented by a 9-digit number. So if we see the SSN has a charge string value, like maybe for some reason a record kind of placed the SSN, so it put the address into the SSN field and put the SSN value into the address. Then according to the domain of those attributes, we know that, okay, that charge string, the address value for the SSN field is invalid, okay? So for the data quality, validate the attribute values is also very important, okay? So now I want to move on to the table join. So table join simply means that we combine related records from multiple tables, okay? So then when we join table, database is not intelligent. We have to tell the database that what other columns from each table must have the matching values. So that's called a join condition, okay? So this shows example here. So for example, we have student enrollment. So in this case, assume that the enrollment so the SID of the enrollment, sorry. I think it's not working. So basically, I can write, instead of writing, let me write. A foreign key. So we have enrollment dot SID is a foreign key reference to the student dot SID. Okay. So this is a foreign key we can specify. So this shows the foreign key, okay? So this notation stands for the foreign key, okay? So for the student table, we only have the student SSN and name, and for the enrollment table, we have student ID and course number. If we want to generate a report that shows not only student ID, but also their name and the course number they take, then we have to combine the two tables together, okay? Because student table does not have course information. Enrollment table does have student ID, but not name information. So in order to get the name information, we join these two tables so that for the records with the matching SID, so one from enrollment and one from student with matching SID, we know that those two records, one representing the student info, the other one representing that student's course enrollment info. So we can join them together. So this is how we do the join. So I think we can do the animation. So it shows how the join is performed. So this is the relation schema. So the relation name, attributes name. And then for the join, usually we simply just append the join table schema together. So the join result, the schema should contain SID as name from student table along with C underscore NO and SID from enrollment table. So for the database to generate the result, if in this case, if we have this query, we are trying to retrieve the CNO and S name, student name, then I think the final result will only contain these two columns. Okay, so it means that we first join student table with enrollment, and then finally we just projection the values for certain columns. That's it. So the table join can be done very systematically. So we can start with student table. We retrieve one student record. and then we combine one enrollment record one at a time. So in order to make sure that each student record is combined with every enrollment record, so we're going to combine one at a time. So if we do the programming, it's very it's very easy. So we retrieve student record, then we combine, we go to enrollment, pick one enrollment record at a time and combine with that student record. So this is how we do it. Then we do have the join condition. So the join condition really says that the two records must have the matching SID. Okay, then we examine if these two records, the first half from student, second half from enrollment, are they having the same SID? Yes. Then this one will be included in the result. And then only signal and S name will be projected. Okay, then move on to the next one. So this time we still use the first record of student table because we haven't finished combining it with every single record in the enrollment. So we finished combining with the first enrollment record. That's why we move on to the next one. Okay. So the same thing, we combine these two records together, then we see if they have matching SID. No, then we're going to drop it because that does not satisfy the join condition. At this moment, we finish combining the first student record with every record in enrollment. Then we're going to move on to the next record in a student, and you repeat the join in the same way. So we take the first record of student, then we start from the first record of enrollment and then try to join them, combine them together, then the SID is now matched, we drop it. Okay, then we still use the second student record, then we move on to the second enrollment record. Now we do have the matching SID, then we will output the only signal and Johnson. So by doing so, we really output the CNO, the course number, along with the correct student name. Okay, so this is called join. So table join is very kind of useful, and because it provides a way for us to combine information from multiple tables together. Okay. And also, I think some of you may, okay, so before, if, for example, if we do not specify the join condition, so what is join condition? This is where clause. So it really shows that here's the database, two records, one from student, one from enrollment, must be have a matching SID in order to combine them together. If not, we do not need to combine them. However, if we miss this join condition, then database will pretty much arbitrarily combine every single record, student record, with every employee record, enrollment record, regardless if they have matching SID or not. Okay, so for example, the second record, we actually combine William's info with the course enrollment for the Jones. So these two are not related. Even we combine them together, it won't give us any useful information. So that's why this combination should never be done or needed. Okay. But if we do miss the join condition, database is not intelligent, it will output all those things. So in this case, the result is definitely wrong. It's showing that Williams taking both SIN number 1000 and SIN number 2000. That's not true because William only takes SIN number 1000. Similarly for the Johns. So that's why this join condition is extremely important. So you should never miss the join condition. Okay, so if you miss the join condition, then you end up with producing a Cartesian product. So a Cartesian product pretty much will combine every given two tables if you do the Cartesian product. And it will combine every record from one table with every record from the other table. So basically, one at a time. So that's not basically Cartesian product will not generate the useful information for you. And then on the contrary, it will generate some wrong information. And if you're not careful, you're going to use those wrong information for the, for example, company's decision-making process, then you will have trouble. So that's why drawing conditions are important. Okay, one more thing I want to just showing that, and then there's several ways to write the join query. The other one for this one is that we use it's called, I know some of you may be familiar with or like the other notation. So we have CNO. So still the attributes are not case sensitive. Then then it will use a different called the table join. So it will join student join, okay, enrollment. Then we have this on condition to specify the join condition. So we have to make sure that student.sid equals to enrollment.sid. So this is another way of writing a join query. So basically you're going to use the keyword join. So table 1 join table 2, then the on condition to specify the join condition. Okay. So this is a second way to write this query. Okay. So both are correct. So depending on which one you prefer. So I think for me, I pretty much use this one. I'm lazy. I don't want to write those join and on. But if you think this one is much easier for you to understand, that's one. Okay. So I think that's pretty much the content I want to discuss for today. So next class, we're going to continue review the table joins, and we're going to see a lot of examples. And I think I post this SQL assignment 1 and 2 to the Blackboard as assignment. So I think right now you're ready to work on assignment number 1. But if you want to work on the assignment number 2, that's fine. So you can try, or you can review what's the remaining slides, then to learn how to do it. Okay? Any questions?